It's a great pleasure to introduce Chris Bousfield. He started his career at the University of Sheffield. He did a PhD there with myself and others, focusing on forest impacts on biodiversity and economics, but then broadening out to think about some of the massive challenges that forests face. And then Chris came to the University of Cambridge and spent a year as a postdoc, and now he's taken up an independent fellowship based back at the University of Sheffield. So we're really delighted to hear from Chris, and I'm looking forward to hearing about some more of his work on sustainable production of wood under the global climate change. So welcome, Chris. Sorry for the technical problems.
Thank you. Yeah, thanks for having me. It's nice to be back here. So today, as Dave mentioned, I'm going to talk about some of our most recent research, which falls under this general theme of sustainable timber production on a changing planet. So, as we're all aware, timber is a really important and vital natural resource globally. So, production of timber occurs in up to a third of all forests globally. It also contributes about $1.5 trillion per year towards national economies, whilst employing at least 33 million people worldwide directly, with many more relying on timber indirectly as well. And because of its kind of global importance to the economy, demand is obviously very high for timber and expected to increase in the future. So this is just a recent estimate that suggests that we might see up to a 50% increase in timber demand between 2010 and 2050. Others estimates place it at between 2 to 3 times greater demand. And this will be due to increased urbanization, population growth, and also potentially as countries move away from more carbon-intensive building materials such as concrete and steel back towards timber. But running alongside this increasing need and increasing demand for timber is the growing threat to the world's forests as a result of climate change. So we have disturbances such as wildfires, pests, diseases, storms, drought, as well as land conflicts for different resources, all predicted to increase in their extent and severity in the future under climate change, which presents a particular challenge for timber production. And this talk today is going to focus on some of our recent work on 2 of these key threats. So firstly, the impact of wildfires on timber production, and secondly, thinking about a potential future conflict for land between timber and agricultural production brought about by climate change. And for the first, the wildfire impacts I want to focus on first. So, as we've probably seen over the last few years, with increasing kind of news coverage of these mega wildfire events around the world, forest wildfires are on the rise. So since 2001, estimates suggest we've lost up to more than 140 million hectares of forest due to wildfires globally. And as you can see from the figure on the bottom right, we're seeing increasing trends in annual losses of forest due to wildfire. So this is a problem that's getting worse and increasing at a global extent. And once we pair with that the fact that most predictions for the future climate under climate change suggests that fire activity is going to be at a greater frequency and severity, this presents a particular challenge for our forests and therefore for our production of timber globally. But the first thing we thought about this problem is that we actually don't really have a good understanding of how wildfires are already impacting timber production at a global scale, and nor whether this has changed in recent years or not. So that's what this first piece of research into this topic that we undertook was trying to address. And it was essentially assessing the impact of wildfires on timber production in the 21st century at the global scale. And within that, we had a couple of key sub-questions we wanted to address. So firstly, simply how much timber producing forest is being lost to wildfires globally, and where are these losses occurring? And then secondly, what are the temporal trends in annual burned area of timber producing forests since the turn of the century? And to understand this problem, we essentially needed to put together different data sources on where we produce timber and where we're seeing changes in fire activity. So firstly, the timber producing forest data, we used two different data sources to sort of pool the knowledge of where timber production is currently occurring, because at a global extent, it's not particularly well defined and understood. But the first data source was from a recent paper by Lessive et al. That essentially parceled out the world's forest into different forest management classes at 100-meter resolution. So you have anything from kind of undisturbed primary forest in the really dark green to the lighter green, which is of interest to this study, which is naturally regenerating forest with signs of management. So these are forests that might be clear-cut, harvested, or selectively logged, as well as those in the blue and orange there, which represent plantation forests. So it's these three categories that we took in this study as our timber-producing forest. And then the second data source was from Curtis et al., 2018 paper in Science, where they took a broader approach to assign the most dominant driver of forest loss in each 10-kilometer grid cell. And there was multiple drivers that they mapped, but the one we're interested in here is forestry, which is in the green. And these are areas where forestry is the dominant driver of forest loss in that region. So we take these to mean kind of areas of quite high intensity timber production, probably mostly clear-cut areas and plantations, where forestry is driving the majority of observable forest loss from satellites. And then we needed some fire data to compare it with. So many studies looking at kind of global impacts of fires rely on this MODIS burned area data set, but we chose not to use that because it's able to pick up quite low intensity fires. And we wanted to make sure that the fire data we were using represented actual intense fires that would lead to a loss of marketable wood and timber in the forest. In many regions, fires are employed through prescribed burning as well. This doesn't affect or damage the timber, so we didn't want to have these as kind of false readings. So we instead relied on this new fire data set from Tukavina et al. That used combined forest loss data with machine learning to identify areas of forest loss that have been caused directly by wildfires. And so we have data for these from 2001 up to 2021. And we can then combine this with our timber and logging data to answer our original questions. The first of which was about how much timber producing forest is being lost to wildfires globally. And when we put these data sets together, we find that there are already significant timber losses occurring across the globe. So this is the first map using the Lessive timber data. And what we have here is essentially any cells mapped in blue where forestry is present, but we don't see much burning of forests in these regions. Whereas anything mapped in yellow through to orange and red represents increasingly large burned area of timber producing forests. And we can see also when we bring up the results from Curtis, they're quite similar, they're quite consistent. We have these hotspots of loss of timber forest due to wildfire, particularly across the western US and Canada, Siberia and Russia, down in southeastern Australia, and then in the Lessive data across much of Brazil, as it is mapping a lot of selective logging going on in that region. And when we take these together, we find that anywhere between 19 to 25 million hectares worth of timber producing forest has been lost to wildfires since 2001. And this is an area roughly the size of Great Britain. We can also look at these losses on a national scale. So here we have plotted per country the total burned area in timber producing forests across that period, that 20-year period. And you can see, unsurprisingly, that some of the northern latitude and boreal north countries dominate in terms of sheer total area burned because of their high fire activity and their large extent of forestry. So countries such as Russia, which has lost between 3 to 6.5 million hectares of timber producing forests due to wildfires. The US, which has lost about 4 million hectares, followed by Canada, which has lost between 3 and 4 million hectares, depending on the data set. But we can also look at it a different way and think about a national perspective, how big is the impact? So we're looking at each country's proportion of timber producing forest that has burned in these wildfires, and that paints quite a different picture. So those northern countries start to melt away in terms of their red, and other countries really stand out. So I'll just pick out two. We have Portugal, that's lost somewhere between 12 and 14% of all of its timber producing forest to wildfires in just 20 years. And then also Australia, after their recent mega fire season a few years ago, we see that they've lost between 6 to 10% of their timber production capacity due to wildfires in that time. So this is going to be, really important at the national scales. It will also lead to an international effect if it has implications for what a country is able to export, and also might change how much they're importing as well if they need to plug that gap in timber. Okay, so that was the first question. That was the where. We also want to think about whether there's any temporal trends we can see in this data. And so when we map the global annual burned area across the years, we see that for both data sets, there's this significant increasing trend. So you have the Curtis trend in blue and the lesser trend in red. We see that both are increasing year on year. In particular, since 2015, the average annual burned area has been 2 to 4 times that of the annual burned area in the previous 15 years. So it's a problem that's getting significantly worse, particularly recently, and particularly in the case of Les Vital, where you can see there's a really large jump in the years beyond 2015. This is happening at the global scale, like I've just shown you, and it's also happening across most global regions. So North America, Latin America, Australasia, and Africa. The only region where we don't currently see a significant increasing trend is across Eurasia. But we can also go into a bit more detail and map these trends on a national scale. So here we have for each data set the trend mapped for each country. So essentially any countries that are in the dark grey have shown no trend over the last 20 years. Any in blue have shown a decreasing trend. And then those in yellow through to orange and red have shown an increasing trend in their burned area in timber producing forests. And the darker that red colour, the greater the size of that increase. And I think two kind of key points to take away from these maps is that firstly, there's far more red, orange, yellow on the maps than there is blue. So there's a lot more countries where we're seeing significant increases. And then secondly, quite concerningly, is that you have 3 of the top 5 timber producers, so the USA, Canada, and Brazil, that are showing increasing trends in at least one of these data sets. So a problem that's affecting some of our largest timber producers that we really rely on globally. And if we take all the countries together that are showing increasing trends, they account for around half of all timber production at the global scale. So it's a problem that's clearly getting worse and affecting at least half of the countries that are producing timber already. So just to summarize that section briefly, we're seeing that wildfires are an increasingly large threat to timber production. We've already lost in just 20 years an area of timber producing forest the size of Great Britain, which could have a value somewhere between $45 and $77 billion worth of timber. The increasing burn trends that we've detected here, when you couple that with future climate change predictions that suggest that this is going to be a really large threat and a growing threat in the future for timber production. And that raises the need to think about how we might avert it or mitigate it. So what's important is that timber operates on multi-decadal timescales in terms of growing cycles. So much of the timber crop that we will harvest in the future is already in the ground today. So we need to be urgently thinking about how we can minimize these fire risks to timber production. And that thinking about how we can mitigate and minimize these risks is something that has led to a bit of further research we conducted, thinking about how we might minimize the risks in terms of what we grow. So there are 2 key methods of timber production globally. In a broad sense, we have the harvesting of native and natural forests, such as that on the left, where you have a naturally growing forest that is harvested for its timber, either clear-cut or selectively, and then the forest is allowed to regrow naturally before it then may be subsequently harvested again once the timber stocks have recovered. The alternative method is through timber plantations. So that's like the picture on the right, where we have these high density, densely packed rows of fast-growing, often exotic timber species that are planted, maintained, harvested on short rotation cycles before the planting begins again. And these are the two broad types of timber production. And we heard from Fang Yuan last month that in terms of ecosystem services, the value of plantations is much lower. So plantations support much less biodiversity, as well as other ecosystem services such as water yield and soil erosion control, compared to natural native forests. However, from a timber production perspective, they're far more efficient. So plantations of the same age are estimated to produce roughly 220% more timber than a natural native forest. So whilst they're worse for biodiversity and carbon storage, they might be much better at producing wood more efficiently. And plantations currently account for around a third of timber production globally, despite only existing on 3% of the world's forests. But this is changing, and we're increasing our reliance on plantations year on year. The potential problem with that is that plantations have to be able to stand up to fire risk and other environmental risks in the 21st century if we're going to continue to rely on them for our timber. So it's been claimed quite frequently that the high density and low diversity structure of plantations makes them particularly susceptible to environmental risks, including fire. And plantations have recently been implicated and blamed for some of the recent megafire events in Chile and Portugal, for example. But at a global scale, convincing evidence of whether they do have a fire effect or not has been lacking. So that was the key question we wanted to understand in this piece of research, is that under identical fire-causing conditions, are plantations more likely to burn than native log forests, and can we rely on them for timber production in a future with more wildfires? So to answer this question, we obviously need some forest management data. Here we rely on the LESIV data that I used earlier, because they parcel out forest management into different forms, of which we're interested in the light green, which is, as I said, naturally regenerating forests with signs of management. So in this study, they'll represent our native timber production forests. And then the blue and orange categories are different forms of plantation forest that we'll use as our plantation data. Again, we compare this with the fire data from 2015 to 2022. And in terms of the workflow, there's three main steps. So the first was sampling. So we were interested in countries with large timber production capacity. So we focused on the top 50 timber producing countries globally, and sampled a large number of native production forests and plantations across each of these countries. Then the second stage is matching, so we can isolate the effects of management type. So we're interested in whether plantations or native forests burn more under the same conditions. We need to control for the conditions that might influence fire. So things such as elevation and slope, weather and climate variables like precipitation, temperature, and importantly, the fire weather index, how much fire weather the areas has experienced, as well as others related to human factors, since humans are the cause of many fires in many parts of the world. So elements such as population density and distance to road. And we've tested 4 different matching methods, which is the panels you can see here. And the red dots represent the difference between native forests and plantation forests in our data set before matching, and the blue after matching. So you can see that matching is doing a really good job at pulling those dots towards the left, and reducing the differences and isolating the management type effect. So we ran this matching analysis for each of our top 50 timber countries. If they fell foul of matching criteria, to know that we've done a good job in the matching, then we discarded them from the analysis. And this left us with 17 timber producing countries that together represent 50% of global production, so a good sample size. And we could then take those forward, put in with our fire data, and model fire frequency in native and plantation forests under identical burn conditions. And this is the output from that. So we have our countries on the y-axis there, and they're ordered by timber production output and the global scale. And the panel on the left represents the raw predicted burn probability in these countries for native logged forests in the green, and then plantation forests in the brown. And the panel B on the right shows the plantation burn effect, so the difference in burn probability between the two production types. So essentially any point that is on the right of that dashed 0 line is a country where plantations burn more often than native forests, log forests under the same conditions, with the dark colors representing significant difference in countries and the light gray shading represent no difference. And what we see is that broadly, and particularly across the temperate countries, there's a strong burn effect in plantations. They're far more likely to burn under the same conditions. This is true for some really big timber producers, such as China and Russia, as well as a number of others that we tested. And when we look across temperate countries, on average, we see this red dashed line at 100%. That's the average effect. So plantations are twice as likely to burn under the same conditions as native log forests across temperate countries. Of course, we see some countries such as the US and Brazil where there's no significant difference, as well as, interestingly, a couple of countries, Australia and South Africa, that go the other way. So here they have plantations burning far less frequently than native log forests, which is very interesting as well, maybe because of the really high fire frequencies in the natural forests in these areas, or perhaps this is a sign of good fire management across the plantations. But that's something for further investigation. But we can also look at this in a more nuanced way and think about how exposed each of these countries are to this fire threat in plantations by mapping on the y-axis. There is the relative plantation wildfire risk. So anything above the 0 line, plantations burn more. Anything below, they burn less. And then we've mapped across the x-axis the proportion of each country's forestry land that is under plantation systems. So we can see some countries that are on the left of this plot have relatively little plantation in their national production systems. So Russia and Italy, whilst they have a strong plantation effect, they don't rely on plantations as much for their timber, so perhaps they're not as much risk. And obviously countries such as the US and Brazil, where there is no effect, are not at that same risk. I'd argue the countries we'd be concerned about are those that are in the top right. So here they have really strong plantation fire risk. So plantations are, in all those countries except for Uruguay, they're more than twice as likely to burn the native natural production forest. And they also have a strong reliance on plantations in their national production system. So there's a high proportion of forestry land that are under plantations in these countries, and particularly so for those with the asterisk. So in that area, it's China and New Zealand that have effectively banned harvesting of native natural wood forests. So they're kind of increasingly exposed to this plantation risk in particular. So just to summarize from the fire aspect, we found that there's increasing trends in the 21st century in terms of burning in timber producing forests. And once we couple that with future climate change, it's going to suggest a large threat to timber production in the future. And we've also found that plantations are at a much higher risk of burning in many countries. But the caveat to that is that they can produce timber at a much quicker rate. So on a national scale, the balance between production efficiency and burn risk is one that's going to vary between countries, and something that kind of needs to be thought about in more detail as to what the best solution is. But all the while, the world is becoming increasingly reliant on plantations for its timber, and that's going to continue to happen. And given what we've seen here in terms of the risk of fire in plantations, we argue that there's immediate need for improving fire management in plantations, either through using the latest sort of fire detection and suppression technology, or perhaps thinking about what is grown in the plantations. So are there more fire-resistant species out there? Will a mix of species in a plantation improve the resilience to fire compared to a monoculture? These are all important questions for future research. Okay, so returning back to those two key threats, we've dealt with the wildfire problem. I'm now going to focus on a small study we did to look at the potential for timber and agriculture land conflict under climate change. So, as most people are aware, agriculture is actually a leading driver of forest loss globally. And if we combine the forest loss and deforestation resulting from cropland expansion and livestock grazing, it accounts for up to 90% of forest loss in recent years. And the world is getting both more populated and richer. both of which are going to increase the demand for food in the future, with some projections suggesting that food demand in 2050 could be double what it was in 2025. And all the while, climate change is expected to drive shifts in what we can grow and where. So this study from Zabel et al. Mapped the projected future change in agricultural suitability for the world's key crops under climate change scenarios. And we can see from the map that there's going to be a significant reshuffling of agricultural area. So those areas in the orange and reds are demonstrating losses of suitability. And there's about 2.2 billion hectares of land that's going to become less suitable for agriculture, particularly across the tropics and subtropics. And at the same time, we see towards the northern latitudes in particular, there are lots of green. So these are newly cultivable areas of land where farming and agriculture has previously not been possible, but is expected to become quite productive in the future as climate change takes hold. And we can see from this plot that most of those greens are focused up in the northern latitudes, which is also where we source currently most of our timber from. So what we're potentially concerned by is whether there's this perfect storm where you have this growing demand for food production, a growing demand for timber production, and in the meantime, climate change is shrinking the available land that is suitable for production of both of these important goods. And so we wanted to assess the potential for this conflict in the future in a broad sense. So within that, we had a few key sub-questions as well. So firstly, just how will agricultural suitability of present-day timber-producing regions change in the future? Where might the hotspots be for potential conflict? And then finally, thinking about how feasible cropland expansion into forestry land is in the future. So to do this, we needed data on both timber production and changes in agricultural suitability. So on the agriculture side, we relied on the data from this map I've just shown you, where they essentially predicted under various future climate change scenarios, the change in agricultural suitability for the world's 17 most important crops, taking into account changes in climate, as well as soil and topographic and other limiters of crop production in those areas. And we paired this with timber production data. So here we've used the Curtis layer that we used in the first study as a good indicator of broad areas of intensive timber production globally. So these are our high intensity, clear cut plantation systems that are probably sourcing the majority, providing the majority of our timber at the global scale. And we merge these two data sets together to think about the extent of changes in present day timber producing regions. And here's what we find. So we tested two different climate change scenarios, RCP 2.6 on the left and 8.5 on the right. 2.6 represents perhaps a best case scenario, whereas 8.5 represents potentially a worst case scenario, but something that's not far off current business as usual. And the scale bar shows the changes in agricultural suitability across our current timber producing regions, with those in blue colors representing increasing losses of agricultural suitability, no change in grey, and increasing reds demonstrate increasing gains of agricultural suitability. And what we find is that across the scenarios, between 27 to 110 million hectares of current timber producing land is going to become less suitable for agriculture. So they're mostly centered across Brazil and also in Southern Europe in RCP 8.5. So these are going to get less suitable for agriculture, probably also less suitable for timber. So this is going to be a problem. But where we want to focus is on these huge swathes of land in the northern latitudes that are colored in red. And we see between 240 to 320 million hectares of forestry land becoming more suitable for agriculture. And that represents about a quarter of all our present day forestry land. And these are obviously concentrated, as you can see, across those northern latitudes and the boreal north, and also across much of China. So in terms of hotspots for potential conflict, we can look at the countries where the changes that we map are greatest. Unsurprisingly, these are some of the biggest timber producers in the world. So we have Russia in the top, the US second, Canada and China. And the colors here represent, so any areas in gray are current timber producing lands that are not suitable now and won't be in the future. Those in purple, there are not many of them, are areas where they are suitable currently and won't be in the future. Those in the blue are areas that are suitable now and will be in the future. But it's these yellow areas we're particularly interested in, and these represent areas that are currently not suitable for any kind of agriculture at the moment, but are likely to be productive and quite highly productive in some cases in the future under climate change. You can see really large swathes of this across Russia in particular, where we have between 40 to 48 million hectares of land becoming productive for agriculture, as well as across much of the eastern US and Canada and northern China. Now, between them, these top 4 countries are the largest timber producers, so they do account for 65% of forestry land globally. But we found that they contain between 86 and 91% of all the newly productive areas for agriculture in present-day forestry land. So they are the most effective, not just because they are the largest, but also because of where they are in the planet and where they are in terms of changes in the future climate. So we might surmise that the conflict is likely to be greatest in these most important timber-producing regions. But that's just mapping the changes, but which is all well. But we might also think that just because suitability changes, that doesn't mean that the land use might change and that agriculture might actually threaten areas that currently produce timber. So we also wanted to ask how feasible cropland expansion might be into forestry land. And firstly, we wanted to think about whether forestry land is under a disproportionate threat in terms of changes in agricultural suitability. And so here we have plotted at the global scale, as well as for each of those major countries, the ratio between what is essentially the share of the global land surface of the timber producing area in that country, compared to the share of newly productive agricultural land in that timber producing region at the global scale. And this equivalence line, dashed line, is a 1-to-1 ratio where we might expect say a country's timberland represents 5% of the global land surface and also 5% of the newly productive agricultural areas. We don't find that equivalence in any of these. So we find that at a global scale, forestry land represents 10% of the land surface, yet it accounts for 27% of all these newly productive agricultural areas. So there's a disproportionate threat to forestry in the future compared to other areas. And that's at the global scale. It's much the same across these major timber producers, and Russia in particular sees somewhere between 5 to 6 times greater threat than we might expect based on its size. So this is a real disproportionate threat to forestry land. But we can also think about how likely conversion might be in terms of how well situated these lands are for conversion. And so here what we've done is compared the newly productive areas inside present forestry land with newly productive areas outside present forestry land. And we find that on average, they're far closer in terms of travel time to population centres, so have much greater access to market and labour. And they're also, on average, very close to current crop producing areas. So you can see that the kind of ease of expansion outwards into these forestry areas is going to be much greater than compared to non-forestry areas where we're seeing between 50 to more than 100 kilometers distance from current cropland on average. So we kind of take that to suggest that the threat of conversion is going to be high in these forestry areas in the future, and that is going to have implications for producing timber globally. And in terms of those implications, if we expect that increasing amounts of forestry land are taken out and converted for agricultural production, we need to think about how we might counter that and maintain timber production. So the first option would be that as agriculture moves northwards with climate change, so too does timber production, and we increase the harvest of wood from those northern boreal forests. I would argue that that's a bad idea because these forests represent some of the last kind of wilderness areas and true primary forests. They also store incredible amounts of carbon in the forest and particularly in the soil that would be threatened by timber extraction. Equally, we could increase harvesting of timber in tropical forests globally, so particularly the Congo and the Amazon that have a large remaining reserves of tropical timber. So we could increase harvest here to make up the shortfall. Again, this is not something we want to encourage. This is going to be really bad in terms of biodiversity, since these areas are kind of powerhouses of biodiversity globally, as well as the carbon stocks that they store. So these are two real but bad options. we'd make the case that there's a better pathway, and that includes firstly improving efficiencies within current agricultural systems. So research suggests that by eliminating or reducing food waste, reducing yield gaps and bringing those down can increase our food production capacity by 1/3 to 60% without the need for any further expansion of cropland. We also think promoting increased dietary shifts away from diets that are really heavily reliant on ruminant meat production that requires a lot of land and is land intensive would reduce the land footprint of the kind of global food system, which would firstly help, but also might lead to quite widespread abandoning of land that was previously required for cattle grazing and pastures, which could then be repurposed for restoration purposes, but also in terms of plantations for timber to maintain those timber supplies. Okay, so I just wanted to finish then by bringing up the slide I showed earlier, which is representing all these different threats that timber is potentially facing in the future. And we've delved into some of these questions. So the fire question we've looked at in a bit of detail, but there's still plenty we don't know in terms of how bad fires will get in the future under climate change conditions, and also in some of the more finer details on how we can mitigate fire risks in our plantations, in particular across the world. We've touched on potential land conflicts in the future in terms of forestry and agriculture, but that's only really scratching the surface. In that scenario, there are also many other potential land conflicts. So with conservation, with restoration, with energy production that will occur in the future. And then these other risks such as pests, disease, drought, storms, I've not even touched upon, and I'd argue that at a global scale, we don't have a good understanding of how timber production may be impacted by these in the future. So I think that there's many potential risks. There's lots we don't know, but that represents a really good opportunity for research, particularly hopefully with colleagues throughout this Centre for Global Wood Security, that we can work on together to think about how we can improve our understanding and our management of these problems to ensure wood security in the future under climate change. And with that, I'd just like to say thank you everyone for listening. Thank you for various collaborators along the way, and I'm happy to take any questions.
Thank you, Chris, for a fascinating talk. So anyone in the room, welcome to ask questions, and of course online. Chris, can you see the chat there? Or,
I can bring it up.
We might want to. You might want to sharing your screen. We'll monitor the chat, and we'll
sit here.
I can see it there. Okay, you can monitor the chat and then read out the question for anyone in the room.
Yeah.
Do anyone have any questions?
Great that I from BirdLife International. Okay. My work is very much focused on policy, international policy around climate, energy, and desertification, so not much, slightly less directly relevant to academia, but separate to my day job, I've been advising, say this, an international furniture company, and I do believe they have goodwill and they are an absolute leader in the industry in terms of efforts on climate and forestry. But also I think businesses that I believe are the best among the peers struggle a lot with forests that they own. For example, in Romania and some other countries, that there's a lot of NGO backlash, which I think rightfully so. But also I think the colleagues in these businesses also struggle a lot in terms of they believe they are trying really hard. So I know it's slightly not exactly directly around your study, but curious your thoughts in terms of what should businesses be doing and what kind of struggles do you see in terms of the ones that want to do good but are struggling? Would you say it's more what's the role of businesses in this?
You briefly repeat the question.
Yes, sure. So the question was about the potential role of businesses in ensuring sustainable timber production in the future. I think It's going to be large because forestry is, predominantly private industry across the world. I think the difficulty with forestry is, say, compared to agriculture, that it happens on such large timescales, particularly across some of the European countries that you're mentioning, and that it can be difficult to see those kind of immediate returns, and it attempts into making shortcuts. I think the kind of setup around sustainability and the FSC, for example, is good, and those kind of things are important in the future, making sure we have clear standards in forestry. I also think that advances in terms of tracking of timber and tracking through the whole supply chain is going to be really important in the future. So there's a really cool work going on in this building that's involved in tracking timber from the point of production all the way through to the point of sale to the final customer, through all those kind of processes, and I think that's going to be really important as well. So you have this clear supply chain. So if businesses are cutting corners and are not doing the right thing, then it's clear to the end user. And then we have to hope that many of these end users are conscious of the impact of poor timber practices, and they can account for that in making those buying decisions. Cool. Okay. Okay, so first question is, can the way a fire starts, whether it was illegal or natural, help in proposing management strategies? Potentially. I think it's really difficult because across much of the world, a lot of fires are caused by humans, particularly across the tropics. It's less sort of natural and more human caused. In most cases, not intentional in terms of its extent, but due to the kind of conditions on the ground and with weather conditions, the dryness of the fuel, the fires tend to spread. So I think there is important difference between human caused and natural fires. So on the natural fire side, we can improve management by improving our understanding and modeling of where these natural fires are likely to occur. So there are some very sophisticated models out there that are able to predict lightning strikes and where lightning strikes might ignite fires. So implementing that more into the kind of day-to-day running and management of forest concessions and plantations could be really useful in terms of getting on top of those fires almost before they spread and turn into a problem. From the human cause side, I think that's really important, and working on spreading awareness and really maintaining this kind of understanding in the local population that small fires can have a really big impact if they spread and given the conditions. So making sure that there's a good understanding of the weather conditions, and whether if someone wants to start a fire to perhaps burn a patch of their field for their agriculture, that they're aware of how best to do that. They don't do it at a time where the risks are too high, and these kind of things might help in maintaining good practice in terms of fire management. There's more. Okay. Yes. John Healy, spatial scale. Can you envisage that the best solution to either or both of the two challenges you outline would be a fine-scale mosaic of intensive wood production and more fire-resistant forest systems, or larger landscape scale blocks? Or the same question for food-based timber production. Okay, so how we identify the best spatial scale of mixing? Do any of the data you access help with this? They don't directly. I think one of the issues we found throughout these pieces of research is that our understanding of exactly where timber production is happening and when is quite poor. So the lessive map is just for the year 2015, and it has various inaccuracies, particularly across the tropics, where it's very hard to detect logging, particularly selective logging, using satellites. The Curtis paper, the data there is just very broad scale. These are general regions where timber production and forestry is happening. So I think one problem at the moment is that we don't really understand at the fine scale, what is happening and where, and potential moves towards a forestry-based data products similar to Global Forest Watch, where we can see exactly where timber harvesting is occurring and when, would be really useful in that regard. I think in terms of whether you look at fine scale mosaics or larger landscape scale blocks, that's really interesting. Something we want to think about in the future. There's quite a strong school of thought that if you have large land scale blocks, then if a fire occurs in them, then you have a good chance of the fire spreading and taking out far more of your production system. So there is an argument towards mosaics of plantations and timber producing forests where it's almost like hedging your bets. If a fire starts in one, it's unlikely to be able to spread further because you have different land uses in between that might suppress the fire. But that kind of, I think at a global scale in particular, that still needs quantification. Okay, I'll go to the next one. Okay, 2 questions. Is there an optimal or recommended size for each timber production unit, particularly related to fire risk? I'll do that one first. That's very similar to the previous question. So in my understanding, I don't know if there is an optimal unit. I don't know if we know that, and that's likely to really depend on where these forestry is occurring and also what type of forestry is occurring. But something particularly worth looking at in the future. I'll just repeat that the way I understand it at the moment is that mosaics of timber production units interspersed with far less flammable land uses could be the way forward in terms of making sure that if fires do occur, they aren't able to spread and burn even more of the timber forest. Could be a way to go. Second question, how can we mitigate social conflicts arising not only from land use, but also from the increasing mechanization of timber production and the challenges associated with fire? That's a very good question, very difficult question. In terms of mitigating social conflicts from land use, I guess forestry is like any other form of large land use. It's often larger corporations and businesses that are running these industries, and we need to be really careful that they account for and make sure that local communities are not being negatively affected by these operations. In terms of challenges associated with fire, I would argue that the fire risk threatens everybody in terms of timber production, not just the producers, because at the end of the day, everyone globally is reliant on timber in many forms and increasingly so. So minimizing and managing this fire risk is going to benefit all elements of society, really.
Mind if I just pick up on that briefly?
Yes, of course.
I really buy into the idea that we have to use our farmland more efficiently, reduce our demand for land through less meat consumption, etc. I just wonder whether we have to take the fact that we're going to need twice the amount of wood by 2050 as a given, or whether we also need to try to think about the way that we're using wood and how we can be more efficient in that to perhaps reduce that demand increase.
Yes, I completely agree. There's many deficiencies across the kind of global timber production system, and I mentioned about understanding if we can improve efficiencies in agriculture, we can improve our production without the need for more land. The same must be true of timber, and that's something that would be really interesting to research in the future. And if we're thinking about wastage, it's high. Also in terms of recycling wood and using it for various uses is important and quite poorly done at the moment. There is also some kind of interesting argument as to whether we might be able to tinker with the structure of the wood, so particularly plantations that produce softwood. There's lots of research going on into how we might edit the structure of these woods to produce a much harder wood so we can grow it quickly, and then it also has many uses and is a lot more long lasting, since the majority of plantation timber worldwide goes towards things such as pulp. So thinking about those elements as well could be really useful in terms of future production and improving efficiencies and really reducing the need for this conflict and this increasing of land footprint for these resources. Some places aren't used for forestry because they aren't suitable for agricultural production because of things like steep slopes or unsuitable soils. These won't change under climate change. Did you account for factors like this? Yes, we did. So the agricultural layer accounted for topography, so slopes, altitude range of crops, also the soil types in those areas. So we can be confident that in their models they don't permit agricultural changes in these areas. So we aren't picking that up in our analysis either. And the same is largely true of forestry. So essentially areas that are unsuitable for agriculture because of those topographic limiters are probably not suitable for large-scale forestry either. Okay, 2 more questions. Do you think it would be possible to model the impact of fire risk on timber productions locally and regionally to see where logged natural forests outweigh plantations, given the fire-corrected yield, to provide guidance on where each strategy should be used? Really good question. And yes, we think it's possible. In the paper on plantations, we do discuss this a little bit. So we picked out Spain as an example where, if I'm getting the years right, the plantation timber is able to come to harvest in around 30 years, 35 years, whereas the native timber production systems take around 120. So there you've got potentially four rotations of plantation in the same time period. You'd get 1 rotation of native wood. So despite the fact that Spain has twice the likelihood of burning plantations, because they're so much faster producing, they sort of still outweigh the fire risk. So that's just one example we picked out. I think it'd be really useful to think about that at national scales as well in the future in more detail. Are there evidence of the opposite of farmland expansion happening in some places? Forestry land expansion into farmland. Ultimately, what would be the preferred criteria to decide whether a heavily managed landscape should be used for food and timber production to reconcile the need for both? Again, very good question. Forestry land expansion into farmland will be happening across the world, I'm sure. That's not something that we've looked into. So that would be, of real interest. I think the areas we might want to focus forestry expansion to in the future are areas of hopefully abandoned farmland that are no longer needed for food production, and they can be then utilized for producing timber instead. Okay.
Is it one more?
One more question. Yeah, final question. Okay. My question is that your research is focused on one service of forest, which is wood production. As we all know, we're nowadays demanding many other services, mitigation, biodiversity conservation. How do you think we should integrate other axes in research to understand the importance of forest conservation and forest policy across latitudes? Really good question. Yeah, so here we're focused on the timber aspect of it, but as you say, forests deliver many other services. Thinking about how we might marry those services together and maximize them is a difficult but really important question. I think that's where there is potential for this land sparing approach to come into play. So there's the argument that timber production in more intense amounts, in terms of, say, plantations or intensely harvested forests, would allow for greater production of timber and a smaller spatial footprint, which permits other areas of forest to be left to provide these other services you talk about, such as biodiversity and conservation, carbon storage, water yield, etc. So I think that definitely does come into play. But I think, yeah, much further research is needed to sort of manage that at the global scale and ensure that, timber production doesn't negatively impact other forest services more than it needs to.
Yeah, all right. Before we thank Chris, I just want to announce the next talk. It will be by Dr. Marielle Smith from the University of Bangor here in the UK. She'll be talking about the structure and function and resilience of mainly tropical forests under global change. And I'm sure that'll be a fascinating third seminar for the centre. Marielle's talk will be on the first Thursday, the 3rd of April, at 1 to 2 o'clock UK British summertime. That'll be, and then it will be on Teams and also here in the Manatee Room for those based in Cambridge as well. So we look forward to that. But of course, Chris, thank you so much for a fascinating talk and a really thought-provoking discussion as well from all those questions. So thank you very much.
Thank you for having me. Thank you. And thanks to everyone in the chat as well. Some really interesting questions.